Okay. Uh, so what we have discussed up to now about statistical tests or even models as well. What is the first thing which we should discuss, which we should consider before moving on to the tests? Number and type of data, number of samples. Very good. Okay, so and then yeah, that will come after, right? After you consider these things, and you can check which test you are going to use. Okay. But before you do that, the real data does not come or may not come in a form where checking these things can be easy. Okay, it may be a very messy type of a data. Okay, especially if it is coming from somewhere else, maybe. Okay, it could be lab data, it could be something which you have seen on site, or something which is taken in real world, like traffic flow or something. So these data sets can be very messy. So to decide these things, you need to first of all organize and clean your data. Okay, before you go on to these things. So that is called as data wrangling. Okay, so you may have to, and what you have been doing, I've given you enough trouble with the read command, right? Every program has their own one. So whatever software, whatever program you are using, you have to insert the data into that program, and before that the data should be prepared from where it can be inserted. Okay, now nobody will like to type the values, 100 values by hand. Okay, so you need it in a format which can be inserted directly. In case of R, we are inserting data from CSV format. Okay, so you need it in a format which can be inserted, then you have to do the insertion. Okay, in some cases we are using other softwares, for example, if you are using MATLAB, okay, MATLAB can pick the data from Excel as well, but you need to be careful about the arrangement of the data, because once you import the file into MATLAB, it takes all columns into account. Okay, so then you have to see which variables, and it will make the software heavier and it will run slowly, and that's why like these programs R and Python are very common. Okay, they are used more because normally you want to work with large amount of data. Okay, with MATLAB it becomes very slow. Yeah, because it will take the whole vector, and until the whole thing is solved, it will not move forward. But these programs are like just take into values and keep on moving. Okay. The shape of the data should be consistent. It should be a tidy format. For example, the number of significant figures you have, how many decimal places you are going to have. Okay, so you need to organize these things. If you are going to put it, if there's an ordinal variable, if there is a binary variable. Okay, so these things should be in the right format. Okay, you want to put it as 0, 1, 2, 3, or you want to put it 0, 1, whatever it is, you have to do it yourself. In some cases, you may have to transform some of the variables. Okay, maybe you are going to use them in a different unit. The experimental data was in inches or feet, but now the equation which you are using is in meters. So you have to transform the entire variable. Okay, or the temperature was in degrees Celsius, but you are now using it in Fahrenheit. Something like this. You may have to transform the variable. Or you have radius, but you are going to use stress, for which you need area. You will convert radius into area. These are simple operations which you can do with one variable. In some cases, you are going to use multiple variables to produce a third variable. Okay, for example, stress using load and area. So you have load, you have area. You want stress. Okay, or you have deflection and you need a stream. Okay, so the transformation can be of different types. Okay, in some cases you may filter the data as well. You don't want unwanted variables, you don't want empty cells, you don't want negative values. Whatever the reason is, how did it come in the data, that's another issue. But now it is there. You may have to filter it. Okay, and like I mentioned, using MATLAB or using even R as well. It is it has 10 columns, but you are not going to use those 10 variables. So that is also a type of filtering. Which variables are important, which are not. Very common example is with the ID, sample ID. It's very important for testing that you have a sample ID. People are often write it on the sample as well. This A1, A2. Later on they can check it, but you don't need it in the software. Okay, so this is also a type of filtering. And then summarizing the data. Okay, summarizing means what? How do I summarize the data?
Just put the important taking.
Summary means what? I give you a paper and I say, give me a summary. What do you do?
Make it smaller. Like
Smaller, maybe smaller.
the main things. Yeah.
Okay, so what about the data now? How do I make it smaller? What are the main things about the data?
The output input.
Output input?
Yeah, the
Okay.
which variable are the most.
Okay, how about each variable?
Each variable only the number or the result. From each, you mean? Maybe the
How do I
highest,
summarize each variable?
highest, lowest.
Highest, lowest, or, and what else? What else do we use to summarize the data? Mean, standard deviation, range, okay. So this all comes under summarization, okay. Then you visualize the data, meaning you prepare pie charts, bar diagrams, line diagrams, okay, whatever is suitable. Okay, so you can see the trend. Okay, and then you can run some models, some statistical tests. Okay, and then you report the results. So this is like what they call as a pipeline, very common terminology for processing the data from start to end. Pipeline means from start to end. So these are the steps which you need to follow when you are analyzing the data, starting with the import, and you go on to the communication stage. So the first three items are called as data wrangling. Okay, we have discussed about graphs and models and tests and reporting, but the first three items are called as data wrangling, how you summarize and organize your data and prepare it for your analysis. So this is called as data wrangling, and 80% of the times you are spending time on this thing. The remaining is either very short. If you did the first three steps correctly, then the analysis, the actual analysis can be very short and easy. Okay, but you have problem with the first three steps, then it becomes very difficult. Okay, so let's say you are getting sensor data from the bridge, okay, or you are getting manual readings from a field logbook, you are getting lab results from a technician. So you have now these three data sets, and you can combine. So the data wrangling may involve. So now you can have three variables, and each one of them is coming from a different source. Okay. So the sensor will not give you the logbook data. The logbook will not give you the technician data. You have to take it and you have to put it and you have to combine them and you have to organize them that they start making sense. And this is how things happen in the real world. Okay, so this is called the Wickham principle of tidying the data, organizing the data, that each variable is in a separate column, each observation is in a row, and each value is in a particular cell. Okay, this is called the Wickham principle of tidying the data. You make sure that your variables are in columns, your rows are in samples. Okay, each row and each column has a particular value in it. Okay, so this standardized data structure is what we normally use in R as well, what we have been using throughout the course. Okay, so for example, did I give you this data? Site inspection data? No? Okay, so again the read command needs to be changed. You're importing a
You have to
CSV file, you can import an Excel sheet as well. Okay, so these are like two different commands for importing the sheets. And then you can, this one will give you the first 6 rows of the data, and you can check it in R, okay, about the structure of the data and everything. And this one is like a summary or structure of the data. We have used this command earlier, but this is like a better alternative to this command. Okay, and summary will prepare summary, like you already mentioned, the mean and the standard deviation and so on. Two read commands.
to read. It's already done.
One for CSV file, which we have been using. The other one for the Excel sheet. You can check it online. The second one, what is the correct format for the second one? Could be different from the CSV file.
Read Excel.
Sorry?
Read Excel.
Yeah, the read Excel.
Okay.
Okay.
I'm checking that.
You cannot open sign inspection, no CSV. We have sign inspection file.
Yes,
Can
yes,
you download it?
yes.
Which one?
I just pasted the
Is it assignments?
just notes.
Assignment, huh? Okay, where did they show there? They're showing there?
Mm. But it is in this folder. Let me assign the directory again.
They do something? CSV we know, right? CSV is the same.
Yeah, now it's clear.
So it's working. The code is working. Anyways, once you have this structure of the data, and you see the first 6 rows, you can have an idea about the data, and you can see how what test you can use and what model you can use and so on. Okay. Okay. Some common commands for data wrangling with the DP layer function or DP layer library. Okay, you can filter the data. Okay, so it will only pick observations which are according to a particular value. Works, right? Okay. So you can filter the value. So once you have looked at the data, you can do one of these things to work with the data. You may filter the values. Okay, I don't need any zero values. I don't need any negative values. Something
This
like
is
this.
also an R.
Yeah, these are all R commands. Supposed to be. Okay, you can select a variable by names, so it will only use those variables. You have 10 variables. You don't want to use all of them. You can select the variable. You can mutate the variable, meaning you can create new variables from the existing ones. For example, you have a load column and an area column. You want to create another column which is stress. So you can use mutate command. You can group the variables for summary. We have already used it earlier. Mix A, mix B, and so on and so forth. Summarize, we have used it earlier. Okay. It gives a mean, median, and so on and so forth. Okay. So the last two commands we have already used. Then we have this operator which is called as a pipe operator, percentage greater than percentage. Okay, and you can combine different functions using this. Okay, so we have the data and we want to filter the data, and after filtering, so filter will pick the observations according to different values, and then we want to group it according to a particular variable. Okay, and then we want the summary. Okay, so I don't want the summary of all the values, and I don't want the overall summary. I want the grouped summary. Okay, so it will first filter the values according to what our criteria gave, then it will group it, then it will summarize it. Okay, which data do we have? Deflection, do we have it?
Yeah.
Do we have deflection data or some sheet with deflection data?
Beam deflection.
Beam deflection, okay.
Do we have to read it?
Obviously. Okay, so this will clean the data. Okay, and what else? It will filter the data where there is no deflection. I believe it is the site data, site inspection data. Site inspection data, yes. It has empty cells as well.
Yeah.
The beam deflection doesn't have empty cells. It's the site inspection data. The one which goes in the last one.
We put the read after the library or?
You already did it, right? You are working in the same line.
Yeah.
So you don't have to read it again.
We don't have.
You already did site inspection in the previous code, right?
Yeah,
So it's already there.
yeah, it's not unexpected. Select site ID.
Was it in this? The previous site inspection data is there, right? In this name.
It's not in field data.
No, when you read it in the last code, you stored in the field data, right?
Yeah.
Yeah. So field data is, you don't have to read it again. It's already there.
But it's not.
But library, you have to still call the library.
Yeah.
Okay.
And
the error is? Symbol, unexpected symbol.
Yeah, this one. What's that?
This one is giving the error because of the hash.
Okay.
Something like this. this one there's no column of site ID, right? There should be.
Site inspection. Yeah, there is site ID, but not underscore.
No underscore. Okay.
That one.
Yeah, it could be.
Site ID underscore. And what else?
Look at the others as well. Okay. Pay attention. So we have mentioned it earlier as well that whatever research we are doing.
Not doing the date, but
Yeah.
I included date and fixing it, but I don't get how.
Because you don't know the formats it's taking.
Yeah.
Anyways. So the research which we are doing, it should be reproducible. Okay, the results and whatever methods you are showing, anybody can take it and he can do the same. Okay, when we were doing our PhD, it used to be a regular, and they were like, I had to take some courses in electrical department, I mentioned it earlier, because of the air. Like, there was no course in civil for air. Okay, so you guys are lucky that you have having it now at the MS level. They didn't have it even at the PhD level. Okay, there were no courses for. So for AI courses, I had to go to electrical department of computer systems. Obviously, they are like we finish here and they start here. Okay, but there were some couple of good instructors who made it easier for me. But the point is, those they used to give research papers to their students as assignments, and the students' task was to reproduce the same results. Okay, so this is how they used to train them, which was very good. Okay, but in our case, like, what reproduce what? You have the data given by me or Dr. I don't know who, the concrete data with the cement content and so on.
Yeah.
Okay, what do you reproduce? You cannot do the experiments again. Somebody already did it. Anyways, but in their case, they do simulation, they do optimization, they do control and so on. So they reproduce the same results. Okay. So the point is, we may have to, or somebody may want to take our results and do it himself, or we may want to do it again in future. Already mentioned a couple of times my bad experience that one reviewer said something to me and I didn't have the old files, I did not save it. I have to do the whole thing from the start. Okay. So one very quick example. I took the code, okay, and the code, there was a problem with the file name, the variable name. Okay, so I said, okay, fine, I will just change it myself. Okay, so I did it at one place, I did not do that at the other place. So that time it worked. Next time, same error. Okay, and you know I'm very brilliant, so I did the same thing again. They let it work this time. Okay, so after 5 or 6 times, I understood no, I should like keep a record and put it somewhere safe. So I just copy it from there. Anyways, so making the research reproducible is not only good for others; it's good for you as well. Okay, so you got the comment from some reviewer, your examiner. Okay, he said, okay, don't do this, do this. So you don't have the old files and the old results. If your research is not reproducible, you will have problems. Another thing is, it makes your research more authentic, more this thing is scientific integrity. Okay, so somebody, like I got an email today. I got an email from a few days ago, and there was a question asked about one of our papers. Okay, and we published that papers 2 years ago. Do you think I would remember? So how would I answer? Maybe we did this. Maybe you would. Okay. Maybe it was this way. Maybe it was this. Now, what would the other guy think about me? He's saying maybe.
Yeah.
Maybe you cheated. Okay. This is what he or she would think. So it makes your research more authentic. The next time somebody comes and he asks you a question, you have the record. You can go back and check and you can give the answer with confidence. And it also helps you to push your work forward. If you have the results, okay, now I want to make it I want to go one step forward. So from there I will go one step forward. Okay. So this is all the reasons why we have why we need the research to be reproducible, and also helps you collaborate with other people. Okay, I already mentioned one example, a spotting of the errors. Sometimes the examiner or the reviewer would say these values don't make sense. Like I saw a paper today. Okay, so they were showing different types of accuracies. So there were four types of accuracy. One of them said for a model accuracy 99%. Good or bad? Accuracy 99%. Come on. What else do you want? Okay, 99%. Other value of accuracy 0. 99 0. Possible?
No, that's
Okay. So now what would I tell him? Can I tell him this is your mistake? No, because I don't know what he did. What I would tell him, these values don't make sense. Okay. If a model is giving 99% accuracy, okay, then they call it, there are different parameters. Okay, like you can have error only value, you can have percentage error. You know this, right?
yes.
So if you are saying error is 0, percentage error should also be 0, right? So it was something like this. So if you say accuracy is 99%, then there is another thing which is called as precision. You know precision, right? So if accuracy is 99%, precision should also be high, right? He is saying precision is 0. Can I tell him his mistake? Because I cannot, because I just see the values. I don't see his program, I don't see his data. Okay, so I will say these values don't make sense. Now how will I correct them? If I don't have my entire record, I cannot see where is my error. Okay, so that's why you need these things. So you have to make sure that you save the entire script of your data. Okay, not just the screenshot or something. You document everything. So you must have seen in these codes, they put a comment for each thing, right? This is for selecting the column, this is for reading the file. So anybody who is reading your code, even if he does not know anything about programming, he knows what this line is doing. Okay, so this is documentation is also a very important part of making your research reproducible. Okay. Okay. So a good project structure is you have your project data and you put your raw data at one place and you never change it. You never touch it. Whatever changes you have to make, you will make it in the other. You will make a copy of the file and then you will start making the changes. Raw data must remain as it is. Even if it is messy, even if it has mistakes, errors, don't change it. Okay, just keep it. This will again help you with the spotting the error and doing something else with the data and so on and so forth. Process data, you have to put the scripts as well. Keep the script as well as the output. Don't just keep the output. And the output can be clean data, graphs and plots of the data, any models you did with the data, figures, any reports you generated. Keep the Word file of the report, keep the PDF of the report. We have one MSc student. I don't know, it's the problem with the student or the supervisor. Okay, like they are saying, okay, we want to produce papers from the thesis. Okay, but the supervisor doesn't have the thesis in Word format. And she is asking I don't know whether even if she is asking or not.
The
Okay,
student.
Who?
The student.
The student should have it, right?
Yeah.
Okay.
How does she, what's if she do?
This is what I'm
Not
saying.
even in cloud, like any emails or.
It can't be.
Whatever. She didn't give it to the instructor or the instructor didn't take it from her. Like in my case, I have keep the Word
At least the
file.
soft copy.
Soft copy, yes, soft copy. Now we don't have printed. Printed is just for the student.
Only PDF
They have PDF only. We don't even have the data.
You can't.
She collected data.
If she has PDF, she can't convert it to Word. I think that is.
She can. I did.
Yeah.
I did. The papers are ready.
But then,
Forwarded to the. Okay, but the problem is she didn't have it.
yeah.
Okay, she didn't have it. And you see, when you convert it, it does a lot of things.
Then
Looking at the file, you will never notice.
Yeah.
If you convert it to Word, just by looking at the file, you will never notice. So if you have to like change one word here or there, conversion works. But to get
Large.
figures and tables, you start copying the tables, it goes all over the place. And sometimes it is like making one table into 10. Every column is a table. Okay? And figures like it's help. The simple graphs, which you take from Excel and put it in a Word file, you convert from PDF to Word and you try to take it, it becomes very difficult. Okay? You cannot control anything. The text is going there, the symbols are all wrong, and so on. Okay? It's better, in that case, it's better to take like a screenshot from it for the figures. Okay? And don't convert anything, just copy the text and take the figures separately, something like this. But the problem was, and then you have a file in the end, how to run the analysis, how did you run the analysis, okay, and that it can be a text file, can be a Word file, whatever, okay, but this is like a standard format which will make your research reproducible, okay, you can run it later on, I don't know how much time it will take, okay, but you start a new script, okay, you load the libraries, you set the working directory, okay, it's just a sequence, okay, then you read the raw data, okay, and then you start the data cleaning steps from the previous exercise, okay. So for any R script, for any Python script, these are some usual steps, common steps: calling the libraries, setting the directory, reading the data. In some cases, you don't do this. In reading the data, you give the full path. That becomes tricky because of the slash. So that's why they say that you set the directory. Okay, but if you are using Python or some other language, okay, the steps will remain the same. Set the libraries, read the raw data, then start cleaning and so on. Clear? Okay. Or you can do it yourself before you read the data in the R or Python, but these programs can do it for you, so that's why it will become easier. If you are doing it with, Dr. Rashid, you know him, right? Dr. Rashid?
Yeah.
Okay, so we are working on traffic safety data. It has a lot of values, thousands of values. So we were making different parameters from the values, because those values are taken from traffic police. So they have their own format, but we want to use it in a different format. So this is what he told me, that he spent like 2-3 hours to do like 100 values.
Yeah.
So now imagine 5,000 values. 100 in 2 hours. So 5,000 values, how many? Okay. So then we went to someone from the IT department. He gave us a code, like what we are doing with the R. Okay. So he gave, I believe, C plus or Python. I don't know. One of them. Okay. But these programs can clean the data for you. That's what I'm saying. Okay. In some cases, you can integrate it with the model, the code itself. So it will clean and prepare the model all in one go. Okay. You don't have to worry about it. But still you need to check it. Okay. So what do? We look at the first 2-3 lines of the data after cleaning. Okay, are they correct or not? Okay, so once you clean the data, make sure it is saved somewhere and you have a look before you go for the modeling or before you save the model. Okay, let's say a researcher is analyzing the data by following these steps. He's opening a raw CSV file, manually deleting the rows, adding a calculated column. He's saving over the original file, making graphs in Excel, and then he's running a t-test and different program. Why are these steps not reproducible? Which of these steps are going against the laws of making the research reproducible? Tell me. What is he doing wrong?
Manually.
He is manually deleting the rows. What's the problem with that? You can't delete. What's the problem?
You cannot.
It's not the road. It's not the road.
Huh?
It's not the roading.
It's not the loading? What do you mean?
If you manually delete, it will be changed.
Okay.
You cannot
Not wrong.
modify the raw data.
He's okay.
It's
So
simple.
you should not do it in the raw data.
Yeah.
So that's the main problem, right?
Yeah.
He's doing everything on the raw data.
Yeah.
So he should make it into a different file and then do it. Okay. If he does it in different file, most of this will start making sense.
Yeah.
Okay. One more step he should do to make it reproducible. So he should not overwrite, and
Clean.
at least one more step he should do to make this entire process reproducible. What is that?
Clean.
Yeah. He's
No,
doing
he has to
manually.
clean the data. Or he is doing it manually.
No,
He can do manually. Huh?
Yeah, but it will take time.
Yeah, he is.
And maybe he will make
He is an
mistakes.
MSc student in UOB, no problem. With time. He has like 3-4 years. Okay, what else? He is doing it manually. Manually can be done. It's not forbidden. It has nothing to do with not making your research reproducible. But he is doing another mistake. Like he's missing something. He's missing something. What is he missing? There's something he should do extra. It's not written here, like what he should do. So he made another file. Now he is doing everything in that file. Okay. So his raw data is saved. Anybody can have a look at his raw data. What else he should do? So he is adding a calculated column, right? And he's deleting some rows, right? Okay. And he making graphs, okay, fine. And he is using, he is going for t-test in another program. Okay. Which program is that?
Script using.
Where is the name of the program? Where is the script? Which rows he deleted? Which rows? Documentation. So he is missing documentation. Okay. So this must be documented, and documentation can be for his own sake. Okay. Everything may not be in the paper or the thesis. Okay, but you need documentation for your own sake. Okay, so for your homework, you create your own data. Okay, you can like take data from anywhere. Like go online, have a data, and just start doing this. Okay, use these functions wherever, however you can, and you save the data, and you have a you have a read a text file which is showing what the script is doing. Okay, and so on and so forth. Okay. So next time, as I said, we will be having this workshop or this interactive session. Okay. So you have a look at lecture number 13, but you have to bring something